terbium, actinium, rubidium, and boron, gadolinium, niobium, rubidium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. Hello, Year 7. I'm Mrs. Smith, and you may recognise me from the Science Department. And I'm here today to tell you all about a chemistry topic. It's one of my favourites, and I'm very excited to share with you. And it is this. The periodic table. Now, you may be familiar with this from the back of your planner or your science rooms, and you look at this and you go, wow, that's science, that is. But what is it exactly? Well, the good news is, this lesson we are going to find out. And in future lessons, we're going to explore exactly what it means for chemistry. Isn't that exciting? So, to tell you about it, what I'd like to do is to tell you about a couple of the people behind it. Two scientists who were also chemistry teachers, called John Dalton and Dmitri Mendeleev. One was English, one was Russian. Now, I thought, how can I do this? I mean, the whole sort of COVID thing, lockdown, I can't just invite them round to my house for a coffee. And video chats, not even Graham Norton's doing that as well as normally, so I don't stand a chance. So yeah, I can't interview them, partly because of the whole lockdown thing, partly because they're dead and that just would take me into a whole realm that I don't want to go into. So I've come up with an idea. And so welcome into Mrs. Smith's special recording studio. Hello everyone, I'm Mrs. Smith and I'd like to introduce you to a couple of my friends. This is Mr. John Dalton. Hello everybody, I'm John Dalton. And this is Mr. Dmitri Mendeleev. Hello everybody, I am Dmitri Mendeleev. Welcome to the interview, Sofa Boys. So, John, maybe you can tell us a little bit about what you discovered about chemistry. Yes, of course. You see, I looked at what the ancient Greeks thought about when they were talking about atoms. Now, of course, they got all the elements completely wrong. They thought there were 4, which is fire, earth, air, and water. Now, we know this is completely wrong. But the idea of atoms, atomos from Greek, this is the idea that you have something so small that if you split it up, you don't have the same thing anymore. So if I took, say, a bar of chocolates, such as this one here, and I took that bar of chocolate and I broke it up, all the pieces would still be chocolate. And I could break it up further and you'd still have chocolate. And I could break it up further and you'd still have chocolate. But chocolate is not an element. It's not on the periodic table. Now, at home, you can pause this video, you can go check. Chocolate is not on the periodic table unless you're a very messy eater. So, once we get to this part, we can split it up into different parts. There might be a little bit of carbon, a little bit of hydrogen, a little bit of oxygen. There's all sorts of things in there. And when you get to those things, those carbons and oxygens, if you split those up, you can't split them any further. You just can't. They're the smallest things that there are, and we call them atoms. And that's the ancient Greek. It means unsplittable. We can't make them any smaller. Thank you, John. That's really, really interesting. So, how many different elements did you know about when you were studying this? Well, there were only about 20, 30 of the elements that we knew. Funny thing, back then we thought that some things like potash
were elements. Turns out we were wrong. They were compounds. We just couldn't split them up. Very interesting. Don't worry, Year 7. We'll be learning all about the difference between elements and compounds in the next few lessons. So, John, you've got about 20 elements, you said, and you figured that atoms were the smallest things. You couldn't split them up any further. So what could you do now? Well, to be honest with you, not a lot. You see, the problem was I've got a list of all the different elements I know of, but I can't do anything with them. The knowledge just isn't there. We don't have the scientific knowledge, so I couldn't do anything else with them. Ah, interesting. Now, Dmitri, I understand that's where you come in. This is exactly where I come in. I am the periodic table genius. Now, what I did, it was very simple. I did not know all the elements either. You do not know all the elements. There is still not enough knowledge. We don't have all the knowledge of all the elements. We are still discovering elements. Now, this is important. I knew that we did not have enough knowledge. And this is what I did. I wrote out what we did know. Now, if you have printed out the worksheet, you will see the things that I knew. I knew the names of the elements. I knew something called the molecular weight. And we'll be doing more about that one next lesson, what it is and what it means. Thank you. So, I knew the molecular weight and I knew the properties. I knew if I have this element, I know how it reacts. And that is important because I started to think, maybe things that react the same should go into groups. So I put them into groups. Now this was quite simple. And then I thought, well, John, now you had the idea at first when you made your list, didn't you? Yes, that's right, Dimitri. And I have my list here. And I've actually, the only thing I knew to do, because we knew a little bit about the atomic weight, the atomic mass, I just put them in order of mass with different symbols. Yeah, that was a good idea. So, what I did was I started to lay them out in groups. Come, I shall show you.
So this is what I said. I said, lithium, you react like this. And beryllium, you react similar. You'll have a slightly larger atomic mass. I put you there. And then we have boron. And carbon. Carbon reacts in a very specific way. And after carbon, we have nitrogen. So nitrogen, again, that does not react too much. It's a bit boring. And then after that, we have oxygen. Okay? Oxygen, very reactive, but even more reactive, I have fluorine. So I have a list. I have 7 elements. They are getting heavier. Their atomic mass is increasing, but they don't have anything in common. And then I come to my next elements that I know of. Sodium. Sodium, it reacts the same as lithium. This is interesting. I put it there. So I have sodium, magnesium. Magnesium and beryllium, they react in a similar way. That's interesting. So let's see what's next. Next atomic mass, aluminium. Very similar to boron. After that, we have silicon. Forms giant structures like carbon. And then phosphorus, which is very similar to nitrogen. And I keep going, and I keep going. And I lay them out like this, and I spot the patterns. Now, sometimes, like for example here, I do not know this element. But I realise that my next element reacts a little bit like nitrogen and phosphorus. And so it cannot go here. It cannot go here. It must go there. Here are two elements that I do not know, that are missing, that we must find. But because I know this, I can say, I think it will react like this. I think it will act like that.
Wow, Dimitri, that's really clever. So you were able to look at what things were like and look at the mass and make a table where all the groups, all the things that go down, all the groups react in the same way. Duh, I am genius. It works very well. And the gap's even more genius. Genius indeed. So there are still gaps on a modern periodic table. This one isn't the most up-to-date one. This one has some missing elements that have got placeholder names put in, just like Dmitri Mendeleev did when he didn't know about the existence of gallium and germanium. So thank you very much, gentlemen, for telling us all about the periodic table. Okay, then year 7, over to you now. So you should have materials sent to you which have all about different elements on. What I need you to do is take a look at it and see if, just like Dimitri, you can build your own periodic table. Sort them out in order of mass and see if they've got anything in common. Or you could see what they have in common, colour them in, just like our multicoloured blocks, and then put them in atomic mass and see if you can make your own periodic table. When you've made that, you can take a photograph of it and show it to your teacher to show that you've done some work this lesson. Okay, so let's say thank you very much, John Dalton. And thank you very much, Dmitri Mendeleev. Our 2 periodic table friends. Take care, year 7, and I will see you next lesson. Bye!